This lesson is about proving similarity with the side, 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 and side angle side theorems. So we are using similarity criteria to solve problems and prove relationships. So we've already done angle, angle. We're now doing side, angle, side, and side, side, side. So side, side, side similarity is if three sides of one triangle are proportional to three sides of another triangle, then the triangles are similar. What does that word proportional means? What does that word proportional mean again? Proportional. It means we're going to get the same fraction, okay? So for each of the sides that are corresponding, okay? So what do I mean by this? So I mean, like, if this was 1, AB was 1, and BC was 3, and AC was 2, and if this was 2, then this would be 4, and this would be 6. So what does that mean? It means, let's see if we can move this over a little. I shouldn't have done that first. Anyway, nonetheless. So what does that mean? It means AB is going to be similar to what? DE. Okay. And then BC is going to be similar to EF. And AC is going to be similar to DF. Okay? So we're going to use this property. It says, are the triangles similar? If so, write a similarity statement. Okay, so for example 1, we're going to compare some sides here. So I'm going to compare PR, this small side, with this small side over SU. Okay, so when I do that, I do get 2 over 3. So the question is, when I compare the other sides, do I get the same ratio? Okay, so I'm going to then compare QP to, and I'm starting here, TS, okay, TS, and that would be, let's do our 2 dots here. This is what I do. I compare sides to sides based on the length of the side, okay? Now, obviously here, this is also 2 dots, and this is 2 dots, because those are isosceles triangles, right? So it really doesn't matter whether we compare QP to TS or TU, okay? But we're going to go around the triangle, so we're going to do it this way. So this time we get 3 over 4.5, and when I reduce that, I get 2/3. And then we're going to do QR over TU. And that's the same, right? So we know it's going to be 2 over 3 because it was 3 over 4.5, okay? So because we get the same ratio here, we can say that PR is similar to SU, right? QP is similar to TS. Whoops. And QR is similar to TU, right? So then we can write a triangle similarity statement. So triangle similarity, we're going to say PQR. Let's do PQR is similar to triangle. So we had P to S, right? We had Q to T, and then we had R to U. Okay, so we're going to say PQR is similar to STU by the side, side, side similarity postulate. And our ratio, if they asked us that, our ratio of, remember, if we go from left to right, let's just write it like we see it. So let's just say our ratio from PQR to STU. What do you notice? it gets bigger, right? So it can't be 2/3. It's got to be the ending over the beginning. It's got to be 3/2, okay? All right, now you try 1 is where we're going next. Go ahead and try that one. Come back to me when you're done. My suggestion on this one is that you go small, small, 1 dot. So I'm going to do 1 dot here, 1 dot here, and then I've got my middle side 2 dots and my middle side 2 dots, and then my big side 3 dots. Now we know I'm putting dots because these are not congruent, so I'm not putting slashes, but I'm putting dots so I can orient the smallest in the middle and the large, okay? So what I'm going to do this time is I'm just going to take my numbers. 14 over 10. If I divide 14 by 10, or if I reduce it, I get 7 over 5. And then when I do my 2 dots, I do 21 over 15, right? What is that divided by in both cases? 3, right? So that's 7 over 5 again. The other ones are divided by 2, right? And then our third one is going to be 28 divided by 20. So what is the greatest common factor of 28 and 20? That would be 4. So that's going to be 7 and 5 again. Because we get the same ratio all 3 times, are the triangles similar? The answer is yes. Why are they similar? It says, if so, write a similarity statement. Okay, so we're going to say triangle. Okay, now here's where it gets tricky. So I'm going to do ABC on the left. So ABC. So notice A is between the 1 and 2 dots. So we want the point that's between the 1 and 2 dots. So over on triangle, the other triangle is going to be point E. So look, between 1 and 2 here, up here. So between 1 and 2 there is E, right? And then when we go from there to B, we go across the 2 dot side. So if we go across the 2 dot side, that's going to take us to F, isn't it? And then we finish with D, okay? And why are they similar? By side, side, side similarity. Okay, and again, if they asked us for, depending on how they asked us for the ratio, if they asked us for ABC to EFD, it would be 5/7. If they asked us for EFD to ABC, it would be 7 over 5. Okay, so is it getting bigger or smaller? That's the way you need to think of that if it asks for the ratio, okay? All right, this next one says, are there any pairs of the triangles below that are similar? If so, write a similarity statement and tell why. Okay, so once again, I'm going to do my 1 dot, 2 dots, 3 dots for the smallest, middle, biggest. Here I'm going to do 1 dot, 2 dots, 3 dots. Okay, and over here, same thing. 1, 2, 1, 2, 3. Okay, so we can do that comparison. So let's go ahead and start with the one on the left. So we're going to do 12 over 18. 6 goes into both of those, so that's 2/3. So that's the ratio we're looking for. So do we get a 2/3 ratio when we do the rest? So we're going to go 13.5 over 20.25. Reduce that in your calculator, and once again, it's 2/3. And you know what? The other way you can tell is 12 over 18 is 0.667, right? And this is also 0.667. So if you can't reduce, you're just looking for the same number, okay? So now we're going to do our 15 over 22.5, and guess what? That is, again, 2/3 or 0.667. So we definitely can write a similar statement for those two. So triangle QRS is similar to which triangle? Okay, so we started at Q, which is between 1 and 3. So 1 and 3 right here, we started at Q. So what is between 2 and 3? 2 and 3. So that's going to be U over here, right? And then we went across QR, so we went across the 2 tick sides. So that would be going towards T, and then we would end with S, right? So these are similar by side, side, side similarity. Got the same ratio. Okay, let's check the other one. So let's do this one now. So we do 12 over 2.5. When I do 12 over 2.5, what did I get? 12 over 2.5, I got 4.8. And then I'm going to do 13.5 over 2.7. So when I did that one, I got 5. Well, I can stop right there because we don't get the same ratio, okay? So we could do the same thing with the middle two, but I'm guessing that it's not going to work either. So let's go ahead and try it, though. So we're going to do 18 over, it's our smallest, over 2.5. So that is 7.2. And then we're going to do our middle one, which is 20.25 over our 2.7. And that's 7.5. So here we go again. So we got our ratio with the first two because it doesn't work with the first and last or the middle and last, okay? So that's our ratio right there by side, side, side. Similarity. Okay, so let's see if you guys can figure out with this next you try which of these triangles are similar, if any of them are. So I'm going to do my little trick again. 1 dot, 2 dots, 3 dots. Comparing the smallest, middle, with large. 1, 2, 3. Here we go again. 1, 2, whoops, 3. Okay, so let's do 20 over 15. That reduces to be, 5 goes into both of those, that's going to be 4 over 3, right? And then let's do our 2 dot, 22 over 16. That would be 11 over 8. Not the same ratio, so it doesn't work for the first in the middle. Okay, so let's try it again. So this time I'm going to do the first and last. I'm going to do 20 over 30. That obviously reduces to be 2/3. Then we got 22 over 33. Again, reduces to be 2/3. And then we've got 24 over 36. That also reduces to be 2/3. So I think it's going to be first to last, but let's try the middle one. So let's do 15 in the last one over 30. That would be 1/2, right? Then we've got 16 over 33. Well, that would be 16.5, right? So that would be definitely not 1/2. What is that? Let me do it on my calculator. 16 divided by 33 is, math 1, enter, 16 over 33. That's it reduced right there, okay? So it's definitely not 1/2. Okay, so that means our answer is in green, right? So triangle, let's do ABC like we did before, is similar to which triangle? So again, we started at A, which was between 1 and 4, or 1 and 3. So we're going to start with G over here, aren't we? And then we went across the B side, which is the 1 dot side. So this is going to be GIH. And why are they similar? By side, side, side similarity. Okay? All right, now the next one says this is side angle side similarity. So it says if two sides of one triangle are proportional to two sides of another triangle and their included angle, which means the angle has to be between the sides, are congruent. The angles have to be congruent, okay? Then the triangles are similar. So again, we're looking at, let's do this here. A, you know what, let's do it in the colors that are here. AB is similar to DE, going towards the angle, right? Then we have angle B is congruent to angle E. Remember, angles don't dilate here, guys, so the angles would have to be congruent. Then we have BC is similar to EF. Okay? So that's why the angles have to be congruent and the sides have to produce the same ratio. So what would that look like again? So that would be like 1 and 2 here. And let's just say this was 2 and this was 4. Got me? So hopefully you can see those ratios. 1 over 2 is the same as 2 over 4, right? Okay, now it says, are these triangles similar? If so, write a similarity statement and tell why. So what I notice immediately here is that these look like they are isosceles right triangles. You guys see this? This side is congruent to this side, and this side is congruent to that side, and they're right triangles, okay? So I'm going to do 2 over 2 square root of 2, that's our top triangle, CD, right, over 2. And that would, the 2's will reduce, so that would be the square root of 2, right? And that would be true of the other side as well, right? 2 square root of 2 divided by 2 is also going to be equal to the square root of 2. So what does that mean? That means that our sides produce the same ratio, right? So we can say that triangle, and this one's a little trickier. It doesn't really matter which side we say is congruent with which side, right? Okay, so triangle, let's just say A, B, C is similar to triangle. And I started with the right angle, so we're going to start with the right angle there. Now, it doesn't really matter which direction we go here because the sides are congruent. So we could say CBD or we could say CDB, okay? And again, why are these similar? By side, angle side similarity. And again, our ratio is square root of 2 over 1, okay? That's what it would be. All right, the U-tries, they're asking us if these are similar. If so, write a similarity statement and tell why. So go ahead and do these and come back to me when you're done. So here, again, look short, short to short, long to long, okay? And then we have these angles that are congruent, right? So we're going to do 12 over 16. Is that equal to our 15 over 20? Okay, now I'm going to show you guys another way to check this, okay? So you can do 12 times 20 here. Is that equal to 16 times 15? Okay, so this is 240, my bad. That's 240, right? Okay, marker, 240. And 16 times 15 is also 240, isn't it? Okay, so if those are equal, then yes, they are the same ratio. Now we could reduce them as well, right? So 4 goes into both of these, 3 over 4. 5 goes into both of these, again, 3 over 4. You could also see that they're the same ratio, which is 0.75 and 0.75. So there's multiple ways to check these, okay? So make sure that you know that all 3 of those will work for you, okay? All right, so this next one, again, we're going short side. Notice we have a right angle and a right angle, right? So short and short over long, with long over long, okay? So we're going to go 33 over 28. And is that equal to 56 over 45? So here again, there's a couple ways we could do this. We can do 33 divided by 28. That's 1.1786, we'll say. And then 56 divided by 45. That's equal to 1.2444. So they're obviously not equal. So are these triangles similar? No. And again, over here, the answer was yes. And then let's write our triangle similarity statement. Didn't do that over there. Forgot. So I'm going to start with T and then go to X and then go to U. I went across the one tick side, right? Okay, so I'm going to say that's similar to VXW, triangle VXW, again, by side, angle, side, similarity. And these two we said were not similar, right? Okay, so then we have this find the missing side given the triangles are similar by side angle side. So we know that these angles are congruent right here, right? Now this one's a little trickier because we got to look and see. We got to use our eyes, okay? So I noticed that the 72 side here is the shortest and the 32 is the shortest there. And then this question mark's a little bit longer than the 32 and the 126 is obviously longer than the 72, okay? So let's do our 72, our one dot over our one dot, okay, and that's going to be equal to our 126 over our question mark. Now, how do we do these? We cross multiply, right? So we're going to do our 72 times our question mark. 72 question mark is equal to 32 times our 126. So that's going to be 72 question mark is equal to 32. 72 question mark is equal to 32. I'm going to divide both sides by 72 there. So our question mark here is going to be 56. Now I can check this to make sure it's right, okay? So to do that, what I want to do is I want to do, this is where our 56 goes, right? So we can say 32 over 72, is that equal to 56 over 126? Now remember, there's a variety of ways to do this. Reduce it, check, or just put it in your calculator, see if they give the same value, or cross multiply, okay? All right, so let's see if you guys can do this next one. Do you try A, and also the you try B. Come back to me when you're done. So here again, I've got a short side and a longer side, and this one looks longer to me and this one looks shorter, okay? So we're going to do 954 over 9, and that's going to be equal to 66 over our question mark. So 9 into 54 is 6, right? What into 66 is 6, 11, right? So let's just double check that. I think that question mark is going to be 11. So we're going to cross multiply again. 54 question mark is equal to 9 times 66. 9 times 66 is 594. 54 question mark is equal to 594. Divide both sides by 54. And question mark is indeed 11. I think I said that wrong, didn't I? So 11 goes in, yeah, because 9 goes into 54 6 times, 11 goes into 66 6 times. So, okay. All right, last one. Go ahead and do it. Hopefully you see that these angles are congruent because they are vertical angles. So again, I see a short side and a shorter side, a longer side and a longer side here. So we're going to do 5 over 18 is equal to 15 over TR. Okay, so 5TR is equal to 18 times 15. 18 times 15 is 270. So 5TR is equal to 270. Divide both sides by 5. So TR is going to be equal to 54. So how do we check this again? We can do 5 over 18. Is that equal to 15 over 54? That's the question, right? 15 over 54, is that equal to 5 over 18? Remember your variety of ways of checking this. You can cross multiply. You can see if they give you the same decimal. You can reduce them. I want to end this lesson with asking you a few questions. What are the 3 ways you can prove triangle similarity? First one we learned was angle, angle, right? Then we learned side, side, side. Then we learned side, angle, side. Okay, what are the 5 ways you can prove triangle congruence? We learned side, 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 then side, angle, side, right? Then we use angle, side, angle, then angle, angle, side, then HL. Okay, so can anyone tell me why there's only 3 in the top and 5 in the next one? Notice this, angle, 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 angle right there. You see that? Angle, angle right there, right? Okay, so then what is the difference between triangles that are similar and triangles that are congruent? So triangles that are similar, the difference, right? Okay, so that sides are proportional versus congruent, right? What is the same? Angles are congruent, okay? For both, okay? That's the thing to keep in mind.